Radiology. So what do you mean by radiology? Radiology is a branch of medical science or a discipline in medical science which uses medical image or radiological image to reach a certain diagnosis or treat the patient. So what are the different types of radiological imaging techniques we know? And those are X-rays, mammography, USG, CT scan, MRI, PET scan and the nuclear scan. Okay, we are going to learn all of this in general radiology section. Now let us move towards the radiation. Why I am taking the radiation initially is that in radiological imaging, the radiation is exposed to the patient and then we obtain the imaging. So this radiation plays an important part in radiological imaging. So you know everything in and out of the radiation. So first of all, what do you mean by radiation? Radiation is any energy which comes from a source, that means it has origin, travels through some material or space, and that is called as radiation. This radiation holds wave particle theory, which means it is an oscillating particle which travels in the form of wave. Okay, so let us move towards the types of radiation. So we have ionizing radiation and the non-ionizing radiation. Before seeing the difference between ionizing radiation and non-ionizing radiation, you need to know the relation between the energy, frequency and the wavelength. So E is equals to H into frequency. So what is the first relation we are able to drive out? That is, energy is directly proportional to the frequency. Higher the frequency, higher the energy. Lower the frequency, lower the energy. Then frequency is inversely proportional to the lambda. Sorry, we'll write it down here. Frequency is inversely proportional to the lambda. Lambda means wavelength. So energy is also inversely proportional to the lambda. So keeping these three equations in mind or relations in mind, let us move towards the difference between ionizing radiation and non-ionizing radiation. First of all, the ionizing radiation. In ionizing radiation, the wavelength is shorter. So let us first see frequency. The frequency is inversely proportional to the wavelength. So we have higher frequency. Now frequency is directly proportional to energy, so we have higher energy. Now let us move towards the non-ionizing radiation. It has larger wavelength. Hence the frequency is low. So is the energy, right? Now whenever a high energy radiation hits on a normal and neutral body, suppose this is a body, this high energy radiation imparts charge to that body, and that imparting of charge causes harm to the body, and it can be even carcinogenic to the human. Hence the ionizing radiation is harmful to the human, whereas non-ionizing radiation is not harmful to the human. Now let us see what are the different radiation comes under ionizing radiations. Those are X-rays, gamma rays, alpha rays and beta rays. In non-ionizing radiation, we have UV rays, visible rays, infrared rays, microwaves and radio waves. Now you guys must be asking, why do we protect ourselves from UV rays? Why do we have ozone? The UVs are kept outside the earth and the atmosphere. We protect ourselves from UV rays. Right. If the UV rays are exposed in higher intensity, it causes burning of the epidermis. So these non-ionizing radiations are not as fatal, as harmful as ionizing radiation. It merely causes the burning of the skin. Okay. Now let us move towards the different investigation which uses these rays. The first one we have in ionizing radiation, the radiological investigation and the nuclear scan. So what do you mean by radiological investigation? What do you mean by nuclear scan? So let us see. In radiological investigation, the radiation used are X-rays, right? And we are going to study the anatomical function by using the radiological investigation. So it uses anatomical function. Okay. Always in case of radiological investigation, the rays or the radiation are coming from outside and goes inside the body, and then we obtain the images. So it is from outside, it's outside to in, And this radiological investigation is only used for investigation purpose. They are not used for treatment purpose. Okay. Now let us move towards the nuclear scan. Here the gamma rays are used. Okay. And they are used for searching or for studying the physiological function of the body. Physiological function. What in the physiological function? That if the hormones are secreted properly, if the bone mineralization is properly or not, if the organ is functioning properly or not, is there any tumor, any changes in the blood, any changes in liver, so or in any enzymatic changes in liver. So all these are going to study under the nuclear scan. Here what happens? They give either the oral or the intravenous route of the radioactive or radio opaque dye, and then they take the image. So what happens? The radiation comes from inside to outside of the body. So the radiation comes from inside to outside of the body, and this nuclear scan can be used for the investigation or in the treatment. And nowadays these nuclear scan are very much used in the prostate cancer treatment. So now let us move towards what are the different